My channel. Today I want to start a new series on how to ensure quality data and exploring and analyzing structured data. We'll focus on structured data with code example, and I'll be using data sets from the cargo as well as some of the code snippets to be able to explain how we can do data analysis on structured data, and also how to make sure that the data is clean and is of high quality. Yeah, we won't be doing anything on model at this time. We just focus on different data sets and different code snippets on how the data is clean, so that we can just build our armory with tools of how to clean data, explore data, and make sure it's good. Okay, that's the focus of this series. Alright, so I'm using the Titanic data set. You can read more on this website about it. So we'll load the data set using the pandas. I'm just taking a look at the last 10. You see the number of attributes that we have on the data set, and this is the ground truth, which is the survived attribute. Now, one of the code snippets we're looking at is how can we count the number of a particular attribute. Let's say in sex now, we want to know how many males or how many females are there. How can we do that? Because if we look at we want to look at this. Let's look at the total number that we have in the old data set. So we say train underscore df dot shape. I think that should give us the total number of rows, which is the first one, 891, and the total number of columns, which is 12, and it's also the number of attributes that we have. Okay, so now out of this 891, we want to focus on this sex attribute and count how many males and how many females are there. Okay, just to do that, all you need to do is just take the data frame on the attribute, and is equals to the particular value of interest, and that's going to give us a series, a Boolean series, where everywhere we have a female in the cell will be true and false otherwise. So for instance, if you look at the last 10, you see that false, false, that means there are no females there. So this is true, true. And if you look at it here, you will see this is male, male, and this is female, female. Okay, so that makes sense. Now the next thing is we want to actually now count how many women are actually there. Now this is something new. We're bringing this here. We're bringing this and we're using the LOC attribute of the pandas data frame, which has the structure of taking, in this implementation, we're using it to take the Boolean series that we have already returned here, and we are combining it with the survived attribute. Now, how does this give us what we need? Now, what is happening here is that this Boolean, the first Boolean series here, is going to serve as a filter. So it's going to filter, we have false, true, true, true. It's going to filter this second attribute. What does that mean? That means everywhere we have a true, that is only what will be returned for this second attribute. All the other places where there are false will be ignored, will be dropped. So you will see here that the length of this is 891. By the time we apply this filter, the first filter, to the attribute survive, it only just returned only the ones that maps the true, in which we have a true in this series. I hope that is clear. Just to be clearer, if we want to take the length of this uh, returned women, you actually see that it's far lesser than this 891, because all this false has been filtered away. Okay, all right, so that's what this is doing. So now it's just returning the values of this. It's a good thing for us to check what is the type of this women. Let's see what type is that. It's a panda call series. Okay, so now that we have this series, we can just, and we're sure from the data set that it's only zeros or one that we have here, so we can just sum this. Okay, once we sum this, all the ones correspond to the women in the data set that survived. They are women, and they also have a 1 in their survived attribute. So that's what this eventually translates to. So we can sum all of that, and that will give us the total number of women that survived. So that's what this is giving us. So the sum women give us the total number of women, and the length of women give us the total number of the sum women. I repeat that sum women give us the total number of women that has a 1, meaning the total number of women that survived, and the length of women give us the total number of women that are in the data set, which is 314. Okay, all right. So, and we can get the percentage by dividing that. Similar thing with this men as well. Okay, now that's one exploration that one of the contributors did. Let's start the second exploration that another person attempted. It is that the person looked at the attribute name and saw that, based on visual inspection, saw that there is a pattern that looks at this name is a composite name, and it has space to demarcate between maybe the last name and the first name. All right, okay, and by heuristics, the author of that code wants to eliminate all the special characters there, like dot, like comma. And so one of the functions to be applied to that name column is this normalized name. And what does it do? So just giving us an example here. And what it does is that it takes something like this, okay? It normalizes by returning, it takes a strings and return a strings, but the strings has now been cleaned up by, first of all, removing all the comma and the full stop, and just putting spaces in between. So let's see the implementation in the code. Alright, so here this x, once it comes in, is using the list comprehension here. Once this x comes in, it splits the x on the spaces. So this is based on the heuristics that the names are spaced with spaces here. If there's anyone that violates that, then this function will definitely miss that. Okay, so on the base of that assumption is splitting on space. Okay, and once this split on space, this the output of this is a list. It gives us a list. So let me demonstrate that. So let's say I pass in this, just to make sure everything is there. So if I pass in this as a list, and I put a split on that, and I split on space, what does it return? So you see it returns a list. So this returns a list where all the what you can call token has been splitted by space. So you start from here, ends here, and put that as the first element of the list. Then it removes this, brings the next one in, and on like that. So that is what this gives us. So we can replace the whole of this list with this one for this instance. Now once that is done, it's now using the list comprehension by iterating through the list and storing each element in V, and each of the element is now stripping them. Each of the element, which is a string, is using the strip function on that. So that strip function starts from here and ends here, and everything that they put inside this first double quote of the strip function are the characters that it wants to strip. Okay, those are the characters it wants to strip from there. Alright, so let's say for instance now you see here is stripping comma, open bracket, close bracket, and all of this. When it gets to it, you want to strip this double quote, but because of the outside double quote is using an escape character to be able to strip this double quote, and it's not using any escape character on single quote. Okay, so by the time you apply normalize on this, you see this. Let's say I want to add something else. Let's say I had a something like this apostrophe on that. You see that I'm splitting it here. So if I'm adding apostrophe by put normalize, you see what happens to that. Yeah, well, fortunately it didn't split that. That's weird. So I actually expected to be able to strip that. Oh, I beg your pardon. I think what is doing the strip is actually at the end, maybe at the beginning and at the end, so it's not within. Okay, so that's right. So let's say I put it in front here. Let's see whether it does strip that. Yeah, so that's correct. So that's something I learned there as well. So the strip is actually taking any of these special characters if they are at the either end, whether beginning or at the end, but not within. Okay, because there can actually be valid names like this. All right, okay, so I'm going to stop there for now. Hope this helps someone out there to be able to understand how the data set can be cleaned to make it in good for downstream machine learning tasks. We continue from there. Thank you.